programming language, like any spoken language, has a series of rules that it has to follow. When we think of the structure of a spoken language, we find that the simple sentences we can construct will contain both a noun and a verb. When I say the dog barks, that's a sound sentence and it conveys a fact about dogs. Since spoken languages are used as a means for people to communicate with each other, that distinguishes it from programming languages. Sort of. You see, computers don't care about how you write your code as long as it can translate it into something it can understand, a series of zeros and ones. For that reason, many of the fundamental features used in programming languages today were not created so that we can better communicate our code to the computer, but rather so we can better communicate our code to other people. In English, you'll find the definition of nouns in the Oxford Dictionary. In programming languages such as C++, you'll find the definition of nouns in header files. The way nouns are defined in programming languages is through the use of the keyword class followed by the name of your noun. Then, depending on the language you're working with, it might end with a semicolon or it might not. Now that we have defined our noun, we can use a list of verbs that aim to describe what our noun is capable of. Although it isn't completely accurate, I'm going to say a verb is no different than a function, which means we can use a couple of functions to better describe our dog. A function could take a number of inputs and or no inputs and spits out exactly one output. To define a function in our dog class, we have to say what noun it spits out, followed by the name of the function, the opening and closing parentheses to store our inputs. This should not be confused with the opening and closing curly brace that we use for our class, since the function will have its own opening and closing curly brace to store the instructions that function performs. The instruction the function performs can be anything from printing something to the screen to some really complicated math equation. Since I'm trying to calculate the dog age given the human age, that would mean that our function input would therefore accept a human age as its argument. I have my function inside my noun, but most commonly what you will see is a function prototype in the header file, and the actual piece of code it runs will be stored in the C++ file. Regardless of what approach you decide to take, our written code will not automatically affect our program. To get our program to run our code, we would have to make an instance of our class. Making an instance means we're physically allocating memory in our program to run our piece of code. And how much memory it allocates will be based off how our noun was defined. If I decide to say Sparky's a dog, then Sparky will be able to form a list of verbs that is defined in our dog class. From there, we can choose to be satisfied with how our nouns are defined, or we could choose to add or remove things from our noun. And just like how with spoken languages, the definition of certain nouns depend on the usage of other nouns, programming languages can mimic that aspect as well. This style of programming where we treat our nouns as objects is referred to as object-oriented programming, and it's a style that's predominantly used in our programming industry.